Hello and welcome. In 1C, we will be talking about sets and Venn diagrams. To begin, let's consider two different groups of things. Let's consider trees and plants. Of course, we have different types of trees. I can list a few over here. We can have oak tree, fir tree, apple trees, different types of trees. And to show that we have a big group, we will use something called a set in math. To represent a set, I list every different item down, and we call these different item members of a set. We separate them with commas, and we add a little braces, a set of braces at the end to show that that's one set, one group. So the set of plants would look something like this. We can have different type of trees. We can have different type of flowers. We can have seaweed. We can have all sorts of different things. The first type of question that you'll get, so this is the first type of question that we'll ask you on your assignment and on your exam, is this. We will ask you to write different contents of a set in using the set notation that we have. So you can pause the video, take a minute, and see if you can come up with the answers on your own. Now let's check. In the first example, we want to write down the sets of the days of the week. So we will have everything from Sunday, Monday, Tuesday, all the way up to Saturday. So this is how I will write everything down. Now for the sets of the years of the 2010s, we are talking about years that's in 2010, 2011, 2012, all the way up to 2019. To list everything out, that's a lot of work. So we will abbreviate, we'll shorten it using 3 dots like this. So this is to show you that we have everything from 2013, 2014, 2015, all the way up. For the set of integers, we will have all the nice round number 1, 2, 3, 4, 5, but they can also be negative as well. So I can have -1, -2, -3, -4, -5. We can also have 0. So we can have something that looks like this, where we have all the different integers going from a very small negative number, -100, -99, all the way up to 0, all the way up to big positive integers. Oh, a little bit of aside, a set can have sets inside. Just like when you go to a restaurant, you can have combo 1, combo 2, the chicken combo, the beef combo. Each combo actually has different items inside, right? So we can have sets within the set. We can also have something that's an empty set. An empty set is when there's no members inside. So I might ask, I might want to write a set of all the Canadian students in the class. We might not have any Canadian students in the class. So I can't put anybody's name inside. So I'll just leave it blank, like an empty set. The next thing that we will have to talk about is the different type of relationship that we will have between sets. So earlier we talked about trees and plants. And what you'll notice is that all the different plants that we have, if I circle them and call them plants, if I do the same thing with trees and call them trees, you'll notice that all the trees inside the tree circle are also inside the plant circle. So we call this relationship a subset. All the trees we can find, they're all in an example of a plant. So we will draw our circles like this. This shows the relationship of a subset. We can have something that's a disjointed set. So we can have animals and plants. And you'll notice that we can never have anything that's both an animal and a plant at the same time. We can have something that's neither. We can have rocks and air and water, and they're not part of the animal set or the plant set. But I can't have something that is an animal and a plant at the same time. So we call that a disjointed set. The third type of relationship is the overlapping set. Overlapping set means I can find something that is a part of both sets. So if the two sets that we have are students and Canadians, we can find Canadian students. We might not find them in our class, but we might find them in a different class. So in this particular case, if I can have something that is a part of two sets, we have something called an overlapping set. A few notes about the Venn diagram. The size of the circle are not important. So you don't have to draw one circle bigger than the other if I have more things inside. Okay, so that's not necessary. A region can have no member. So earlier, when I draw a circle like this, we might have a class where everyone in the class, all the students in the class are international students. So I wouldn't be able to find any students that's Canadian at the same time. So this might be empty. But we will still use the overlapping set if we might have members in common. So in this Canadian students example, I would still draw it like this because in a different class, I might find Canadian students inside. Over here, we'll sort of show you, quickly highlight what the different region means. So in order to find things that's both a plant and a tree, it's just in the tree circle in this case. To find something that's a plant but not a tree, something like roses, sunflowers, seaweeds, we will find them in the plant circle, but outside of the tree circle. We cannot really find anything that's a tree but not a plant at the same time. So we wouldn't be able to find it in our Venn diagram. Finally, the outside where it's both outside the plant circle and the tree circle at the same time, that's when we have something that's not a plant and not a tree. For the disjointed set, something like animal and plants, I can't have anything that's both an animal and plant. We wouldn't be able to find it in the Venn diagram. But we can find animals in the animal circle. We can find plants in the plant circle, right? Plants and not animals. Or we can find something that's neither, so they will be outside of both. Now the two that I just showed you, the subset and the disjointed set, this is just a quick sort of highlight. But for the disjointed set that I'm going to show you now, understanding what the different region represent, that will be more important. Okay, so this part will be more important because we will use this when we do our question later on. So for students and Canadian, we are looking for something that is inside both circles. So that's the overlapping region that's in the middle. Okay, so that's where we find Canadian students. To find students that are not Canadian, so international students, they would be outside of the Canadian circle, but inside the student circle. For Canadians that are not students, they would be in the Canadian circle, and they wouldn't be in the student circle. And finally, for something that is not a student and not a Canadian, they would be outside of both circles. The very first example that we give you are something called a categorical proposition. Because besides talking about the trees and the plants, we use the word all to tell us what the relationship is. There are 4 different categorical propositions that you will have to know. We have the all, the no, and then the some. So here are some examples. We can have all trees are plants, all no animals are plants. We can have something that says some students are Canadian, some students are not Canadian. We don't have to remember the name categorical proposition, subjects, or predicates. We also don't have to remember the name like sets and members. Those are not important. The important thing, though, is to recognize that we have what the meaning of these categorical propositions are. Are we having a disjointed set? Are we having a subset? Are we having an overlapping set? So here it's sort of like a picture overview. When I say all trees are plants, for example, all trees are plants, we have something that is a subset. And the picture would look like this. If I say that we have, no animals are plants, no animals are plants, we have a disjointed set, right? Because the animals cannot be inside the plant circle. No animals are plants. If I say that some students are Canadian, then we have overlapping set, because I can have some of the students in the student circle that is in the Canadian circle at the same time. Now, to show that we have some students are Canadian, we'll put a little X here to show that we have someone that's here, right? Someone that is both a student and a Canadian at the same time. To show that some students are not Canadian, we want to show that we have some students in the student circle, but not in the Canadian circle. So we would put our X in a slightly different position over here. So the second type of question that you'll get on your assignments and exams for this section is this. We will give you the different, we'll give you a relationship, and we'll give you these 4 pictures over here. So what we'll ask you is this. We wouldn't show you the different relationship that's on top. We'll just show you the 4 picture. And we might give you an example, say, no cell phones are chips. And I would ask you, what kind of relationship do I have? How do I represent them? No cell phones are chairs. So I can't have something that's a cell phone and a chair at the same time. So they have to be a disjointed set. So that would be our answer. So you have to know that this picture over here represents that we have a disjointed set, and no cell phones or chairs are telling us cell phones and chairs, these 2 sets are disjointed. I might have a slightly different question when I ask you, when I say all cell phones are electronics. All cell phones are electronics. Then I know that the cell phone circle, the cell phone set, all belongs inside, are all inside the electronic circle. So we have this picture, we have the subset picture. So you have to know what these 4 diagram means, and we have to be able to sort of pick the correct one if I give you a categorical proposition. Let's look at a slightly different example. Here we have something. Here we have the categorical proposition. Some birds can fly. And of course, what does that picture look like? Some birds can fly. Some birds can fly. So let's try to draw it yourself. See if you remember. Some birds can fly is something like this. Now, you don't have to have the flying animals on the left. You can have birds over here and flying animals on the side. Doesn't really matter. But when I have some birds can fly, that means that I have something. I put the X over here. I have an overlapping set. I have something that is a flying animal and something that's a bird. So you notice that is exactly the same as some flying animals are birds, right? I have flying animal, something that's in the flying animal, and they are also bird at the same time. But we cannot really say that all flying animals are birds, because we don't know if, in order for all flying animals to be birds, we have to be able to place all the flying animal inside the bird circle. In other words, I cannot find anything. I should not be able to find anything out there. Right? I should not be able to find anything out there. Now, does the information that we're given, some birds can fly, that doesn't tell us what happens here, right? That doesn't tell us if I can have flying animals that's not birds. So it doesn't tell us anything here. So we cannot say that all flying animals are birds. And that doesn't tell us that. Finally, we will ask you a question on Venn diagram. Now, before, at the very beginning, we'll show you this example where we show you how to draw a Venn diagram. So to draw a Venn diagram, in this particular case, it asks us to draw a Venn diagram with students and international as the 2 different sets. Okay, so I draw students and international for our 2 circles. This will be given to you in the question. This is given to us in the question here. So we're not using Canadian because of that. Let's put the different numbers down. Students who are international, we have 55, and we put it down here, both inside the student circle and inside the international circle. For the 13 Canadian students, we put them there. They're inside the student circle, but outside of the international circle. For the international teachers, we put them inside the international circle, but outside of the student circle. And finally, Canadian teachers, they're not students, they're not international, we put them outside. So this is how we would come up with a Venn diagram. Now, the third type of question that you'll get is this. You'll get a Venn diagram, and you wouldn't get the table over here. So we'll give you a Venn diagram. So we'll give you Venn diagram down here. And we might ask you questions like this. How many international students, okay, are there in the school? And you have to know, oh, I need to find how many are there in the international circle and in the student circle, and that would be 55. We might ask you questions like this. How many students are there? We might ask you how many students are there. Well, we have to add up everything inside the student circle. We have to add that up. So we have to say 13 plus 55, and that would be 58. So we have 58 students in the there in total. We might ask you a slightly different question, right? We might ask you, how many people are international, but not a student in the school? So how many people are international, but not a student in the school? So you have to then know that we are looking for international people, but not a student. So that would be out here, and that would be 3. And our answer would be 3. So the third type of question that you'll get will show you a Venn diagram and will ask you to find the number of students or number of people on there. So that would be all. That's the 3. So the 3 types of questions that you'll get in this section. Write the set notation. Select the proper categorical proposition representation, and which picture represents the correct categorical proposition. And then looking at the Venn diagram and finding out how many are there.